Evaluate any trig function at a special angle or a quadrantal angle. Special angles are multiples of pi over 3, pi over 4, or pi over 6. Quadrantal angles are multiples of pi over 2. That's what this video is about. Alright, take a look at number 13. It's all about drawing sketches. So here's a picture for number 13. Secant is the reciprocal of the cosine function. So we know that secant is 1 over the cosine of pi. So keep that in your mind. Now, where's pi? Well, here's pi. Pi is a semicircle. So if I were talking about an angle in standard position, it would start here and then it would end here. Okay, so this is what pi looks like. So we're talking about this spot right here. And let's talk about what the cosine is. Well, we know that this is the point -1, 0. And we know that cosine is an x value on the unit circle. So the cosine of pi here is -1 because that's the x value. So that makes this 1 over -1, which of course is simply -1. So that's going to be the answer to number 13. Alright, let's take a look at number 14. Now, cotangent is the reciprocal of the tangent function. So we know we're talking about 1 over the tangent of pi over 2. Now, so again, looking at our unit circle thingy, we know that right here we have the point 1, 0. This is 0, 1. Alright, this is -1, 0. And this is the point 0, -1. Now, pi over 2 is right here. Well, if this is the initial side, then this would be the terminal side of pi over 2. Alright, so focus your eyes on that spot right there. Now, tangent is sine over cosine. So in this case, the tangent is going to be, the tangent of pi over 2 is going to equal 1 over 0. Alright, that's y over x, sine over cosine. So that's undefined. However, the cotangent is going to be the reciprocal of this. So the cotangent of pi over 2 is going to equal 0 over 1, which is not undefined. So that's going to be 0. Alright, so keep that in the back of your mind. If you have something that's undefined, the reciprocal is going to be 0. If you have something that's 0, the reciprocal is going to be undefined. So I guess it wasn't really helping me to write 1 over tangent, other than to remind me to do the reciprocal. So I'm just going to erase that and just go ahead and say that the cotangent is 0. Alright, well, for number 15, I know that secant is the reciprocal of the cosine function. So I'm going to start off by finding the cosine of, well, I shouldn't have put theta. I'm going to start off by finding the cosine of 0. And whatever that is, I'll do the reciprocal of it, and that will give me the secant. Okay, well, the cosine, well, first of all, 0 is right here. Right? 0 is right at the very beginning. Now, the coordinates of this point are the coordinates 1, 0. Now out of this, the cosine is the x value. So the cosine of 0 is 1. So the secant is going to be the reciprocal of that. But the reciprocal of 1 is still 1. Number 16, cotangent of pi. Well, cotangent is the reciprocal of tangent. So let's start by finding the tangent of pi. Alright, here's my unit circle. Here's pi. Alright, the initial side is here. The terminal side would be here. So focus your eyes on this spot right here. This is the point -1, 0. Now tangent is sine over cosine. So tangent is going to be 0 over -1. That means the cotangent, which is the reciprocal of this, is going to equal -1 over 0, which is, of course, undefined. Alright, so those were all quadrantal angles. Let's get into some other types of angles. Okay, before we get into this, let's remember our chart of special angles, which we should have memorized. Alright, first of all, you should have memorized the sine of pi over 4, which is 1 over radical 2. Now some people write this as radical 2 over 2, and that's the same thing. But you also should have memorized the sine of pi over 6 is 1/2, and you should have memorized that the cosine of pi over 6 is radical 3 over 2. Now if you memorize these three things, you should be able to figure out everything else on this chart. First of all, you should now know the cosine of pi over 4, because that's the same thing as the sine. So that is also 1 over radical 2. Second of all you have to know is that these two are reversed for what comes next, because we need to know the sine of pi over 3, but that's going to be radical 3 over 2. And we need to know the cosine of pi over 3, and that's going to be 1/2. See how they just crisscross? So you should memorize all of this. And then we know that tangent is sine over cosine. So if I want to find the tangent of pi over 4, I'm just going to do this divided by this. Now the denominators will cancel out, so it's just 1 over 1, which equals 1. Now the tangent of pi over 6, again the denominators will cancel out, so it's just 1 over radical 3. And if I want to do the tangent of pi over 3, again the denominators will cancel out, so it's just radical 3 over 1, which is just radical 3. So by memorizing these three values, we can get a total of 9 values out of it. Well, 18 if you count the reciprocals of all of these. Anyway, because some of the questions that we are being asked are in degrees, let's pause and understand that pi over 4 is the same thing as 45 degrees. Pi over 6 is the same thing as 30 degrees, and pi over 3 is the same thing as 60 degrees. So if they ask me for the sine of 30 degrees, I know that's 1/2, and so on. If you're trying to evaluate a trig function of a particular angle, you need two things. You need the reference angle and the quadrant. So let's start by finding the reference angle. Let's draw a little sketch. Alright, 225 degrees. Remember that this is 90 degrees right here. This is 180. And this is 270. So 225 is somewhere in this third quadrant. Okay, so if this were a standard position, alright, 225 degrees is going to be somewhere in here. Now, we need this reference angle. So 225 minus 180, what's that? Oh, look, 45 degrees. So we have a reference angle of 45 degrees. But notice that the quadrant is in quadrant 3 here, so keep that in mind. But let's write this down. So we're dealing with a reference angle of 45 degrees, and we are in quadrant 3. So sine, cosine, and tangent using this information. So the sine of 225 degrees is going to be the same thing as the sine of 45 degrees, except for maybe it needs a negative on it. So we'll use a reference angle. So remember, sine of 45 degrees is 1 over radical 2. So we're going to have 1 over radical 2. Now look at the quadrant to decide if it needs a negative sign. Well, in the third quadrant, the sine function is negative. So it will be negative 1 over radical 2. How about the cosine function? Again, we'll use the reference angle. And again, the cosine of 45 degrees is also 1 over radical 2. So I have 1 over radical 2. The only question is, does it need a negative sign? Well, in this quadrant, cosine is also negative. So yes. Now how about tangent? Tangent of 225. Well, since we have, what happened to my negative sign? Since we have both of these visible, we can just look and know that tangent is sine over cosine. So it'll be this one divided by this one. Since these are the same, that's going to be 1. So that's how you find all three trig functions without using a calculator. Let's do that again for negative 750. Alright, keep in mind that negative angles are going to be clockwise. Alright, let's figure out exactly where this thing is. Here is the initial side. Now, I'm going to go clockwise because it's negative. If I went all the way around, okay, and back to where I started, so far I went negative 360 degrees. Alright, I'm still far away from negative 750. So what if I went all the way around again? All the way around and again back to where I started. That's another 360 degrees. Okay, 360 times 2 is 720. So at this point I've gone negative 720 degrees. So I'm getting close. I only have another 30 degrees to go. So if I went an additional 30 degrees, then I will land at negative 750. Okay, notice that right here I was at negative 720 and now I'm at negative 750. So this reference angle is 30 degrees. Alright, a reference angle is always written as a positive. So we need that. So keep in mind that the reference angle is 30 degrees. And be aware of the quadrant in which we lie, the fourth quadrant. So with this in mind, we should be able to do the three trig functions easily. Okay, so here we go. I'm going to do the sine of negative 750 Okay, using the reference angle of 30 degrees, that's not what I wanted, this is what I wanted. I'm thinking sine of 30 degrees is 1/2. So this is going to be 1/2, except for maybe it needs a negative sign on it. In this quadrant, the y values are negative, so yes, it will need a negative sign on it. How about the cosine of negative 750? Okay, again, I look at the reference angle. The cosine of 30 degrees is radical 3 over 2. So I go radical 3 over 2. Do I need a negative sign? Well, in this quadrant, the x values are positive. So no, I don't need a negative on this one. How about the tangent? Okay, the tangent of negative 750 is just going to be sine over cosine. So it's 1 over radical 3. And since 1 is negative and 1 is positive, I will get a negative result. Okay, so that's it for number 18. Alright, let's do it again for negative 240 degrees. Okay, here's the initial side. So if I go to here, so far I've done negative 180. I shouldn't have put the arrow on it yet. No arrows. Now if I went to here, that would make it negative 270 degrees. That would be too far, so I'm not going to go that far. So I know it's going to be somewhere in this quadrant, though. Somewhere in this quadrant. Okay, and so here I am landing negative 240 degrees. Now remember, right here I was at negative 180, and here I'm at negative 240. So I need the reference angle. That's the difference between those two things. Okay, so I can really ignore the sign and just do 240 minus 180. That is 60 degrees apart. So that's going to be my reference angle, is going to be this 60 degrees. So let's make a note of that. The reference angle is 60 degrees. Okay, so, and pay attention to the quadrant that we're in. So let's go ahead and do the 3 trig values. So if I want to do the sine, well, I shouldn't say the sine of 60. I'll say the sine of negative 240. But as I do it, I need to think about the reference angle. So we're talking about the reference angle of 60. Sine of 60 is radical 3 over 2. So I've got radical 3 over 2. The only question is, do I need a negative sign on it? Well, in the second quadrant, the sine function is positive. So no, I don't. How about the cosine? So now let's talk about the cosine of negative 240. Well, let's start with the reference angle, cosine of 60. Cosine of 60 is 1/2. Okay, so that's going to be 1/2. Do I need a negative sign on it? Well, yes, I do, because in this quadrant, cosine is negative. Alright, now how about the tangent of negative 240? Well, the tangent is just sine over cosine. So the denominators will cancel out, but I'll be left with radical 3 over 1, which is just radical 3. And since 1 is positive and 1 is negative, it will be negative. So these are the three trig values. Alright, now number 20 is going to be the same thing, but instead of using degrees, we're talking radians again. Now, because this is a special angle, see the pi over 3, we know right from the beginning that the reference angle is going to be pi over 3. Alright, we still need to do the sketch so we can think about what quadrant we're in. So I'm going to do that. Maybe I'll do it up here though. Okay, because I'm talking pi over 3's, then I'm going to divide this picture into pi over 3's. So that would be like this. Notice I've divided the top half into 3 parts. That's why it's pi over 3. Now we need to go to 5 pi over 3. So if this is the initial side of some angle, 1, 2, 3, 4, 5 pi over 3 would be right here. Alright, so we are in the 4th quadrant. So keep that in mind. Now using the reference angle, we should be able to talk about our 3 trig values. So let's talk about the sine of 5 pi over 3. Well, the sine of pi over 3, first of all, is radical 3 over 2. The only question is, do I need to put a negative sign on it? Well, in this quadrant, the sine function is negative because it's below the x-axis. So yes, I will need to put a negative on it. What about the cosine of 5 pi over 3? Well, let's look at the cosine of pi over 3, which is 1/2. The only question is, do I need a negative on it? Well, in this quadrant, the cosine function is positive because it's to the right of the y-axis. So no, I do not. And then what about the tangent of 5 pi over 3? Well, tangent is sine over cosine. The denominators cancel out, so that's going to leave me with radical 3 over 1, which is just radical 3. And since one of them is negative and one of them is positive, the tangent will be negative. Alright, I'm going to try to do these last ones much faster now that I've done several examples. So, we know the reference angle is obviously pi over 6. So focus your eyeballs on that. A quick sketch, because we're talking pi over 6's, let's sketch some of those. Okay, so pi over 6's look like this. Because there's 6 of them in the top half. We need to go negative 1 of these. So that's going to look like this. Alright, standard position. Negative is clockwise. So we're talking about right here. Alright, so once again we're in the 4th quadrant. So let's get going talking about sine of negative pi over 6 and cosine of negative pi over 6 and tangent of negative pi over 6. Well, look at the reference angle for a start. So what's the sine of pi over 6? Well, we've memorized that the sine of pi over 6 is 1/2. Do we need a negative sign on it? Well, in this quadrant, the sine function is negative, so yes. Alright, we've memorized that the cosine of pi over 6 is radical 3 over 2. In this quadrant, cosine is positive, so I don't need a negative sign. Tangent is this one over this one, so that's going to be 1 over radical 3. And since only one of them is negative, it will be negative. So that's number 21. Okay, I see that my reference angle is pi over 4. So keep that in your mind. And since we are dealing with pi over 4, let's draw pi over 4. So far, those are pi over 2's. Now they are pi over 4's. We need to go 11 pi over 4's. So if this is standard position, initial side, from here I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to end up here. Okay, so as I begin to answer all the questions, I am going to use the reference angle, but pay attention to the quadrant. So when I do the sine of 11 pi over 4, I'm thinking, what's the sine of pi over 4? And I know that that is 1 over radical 2. Do I need a negative sign on it? Nope, in this quadrant the sine function is positive. Now how about cosine? Cosine of 11 pi over 4. Oh, what's the cosine of pi over 4? Well, that's also 1 over radical 2. Do I need a negative sign on it? Yes, in this quadrant cosine is negative. And how about the tangent of 11 pi over 4? Well, tangent is sine over cosine. These will cancel each other out completely and just make 1. But since this is positive and this is negative, it will be negative 1. Okay, how about number 23? Well, I think this is actually a quadrantal angle. So there won't be any reference angle this time. Instead, we will just use coordinates. So here is pi. Okay, so if this is my initial side, like I always do, this is my terminal side, here's pi. Okay, but we're doing 7 pi, so this is 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. So 7 pi is going to put us right here. Okay, the coordinates of this point are negative 1, comma 0. So we're going to use those to answer all the questions. So when we do sine of 7 pi, whoa, what am I doing? Alright, sine of 7 pi. Sine is the y value. So sine of 7 pi is 0. When I do the cosine of 7 pi, cosine is the x value. So that's going to be negative 1. When I do the tangent of 7 pi, tangent is sine over cosine. 0 divided by negative 1 is 0. Alright, so I think this is the last problem, number 24. So let's draw one more picture. Again, the reference angle, we're back to reference angles again. The reference angle is pi over 6. So therefore, let's draw some of those. Alright, so these are pi over 6's because there are 6 of them. Remember that negative angles are measured clockwise, so I need to go negative 7 pi over 6, so that's going to be like this. Negative 1, 2, 3, 4, 5, 6, 7. So that's going to put us right here in the second quadrant. So, time to do the 3 trig functions. So if I do sine of negative 7 pi over 6, in my mind I'm thinking sine of the reference angle, sine of pi over 6. And I know that that is 1/2. Remember? Yeah, we memorized it. The only thing is, do I need a negative sign on it? Well, in this quadrant, the sine function is positive, so no, I don't. What about the cosine of negative 7 pi over 6? Well, I'm thinking about the cosine of pi over 6, and I know that that's radical 3 over 2. Do I need a negative on it? Well, in this quadrant, cosine function is negative. So yeah. Now tangent. Tangent of negative 7 pi over 6. Tangent is sine over cosine. The denominators will cancel out, so that's going to leave 1 over radical 3. Since one of them is positive and one of them is negative, the tangent will be negative.